Whoa, 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 whoa. Okay, so welcome guys. So in the previous, So in the previous video, we proved like the some funny probability inequalities. Like the first one is the Markovian inequalities, which is somehow very elementary. And also one can easily check that if you can change a little bit and use Markovian identity to prove the Chebyshev inequalities. So we have two inequalities. One is Markov, one is Chebyshev. But actually, there's many other interesting probability inequalities. So I make a PowerPoint just for fun. Okay, so in this video, let's prove this Paley Zygmund inequality. Okay, so Zygmund is a smart guy, I guess. Zygmund has a real analysis textbook. Okay, so let's see. Actually, I already write down details, so you guys don't have to copy. You can just see my PDF, and I will open the websites that you guys can download this PDF just for fun. Be sure to subscribe to my channel. Okay, so if z is greater than 0, greater or equal to a random variable, so this is the same as the Markov conditions. We find a variance. By the way, this is copied from Wikipedia. So theta is from 0 to 1. Then pz larger than theta ex. Ez is greater or equal to 1 minus theta squared, ez squared minus e expectation values ez squared. Okay, so if you go to see the Wikipedia, then Wikipedia say that first you just write down is, and the first thing is at most, the second thing is at most, because you show us inequalities. Okay, so Wikipedia didn't give you the details, so let me help you guys. So the idea is that let's say f to be a PDF, so f to be a probability distribution. So remember that is a function which you continuous function, okay, or integrable function from 0 to infinity. F of z dz is 1. And the FO is greater or equal to 0. Okay, so the Cauchy-Schwarz identity is fg dx squared. Integral will be less than f squared dx. Integral of g dx, g squared dx. Okay, so you can go to my video. I will leave the link below if you don't know how to prove Cauchy-Schwarz inequalities. I have many videos to prove it. Okay. So EZ, right? EZ should be infinity to infinity f of z dz, right? But we said that z is greater or equal to random variable, so we can eliminate the infinity to 0 part, and we got this z f of z dz. And it's obvious I can write down as 0 e theta ez z f of z, and theta ez infinity z f of z dz, right? So basically it's these two parts. Okay, so wiki guy like to use like the major theory, so this one means the indicator function. Okay, but so I suppose you don't know real analysis. Okay, so if you know, then it's fine. Yeah, you can write down as a fancy way. Okay, so basically this is a proof. Okay, so let's quickly go through. Okay, so easy, right? Easy. Oh, easy. Okay, it's an E, right? Yeah, it's basically you write down as these two part, right? I written as 1 and 2. So 1 is this 0 to theta ez z f of z. So this is less than 0 to theta ez f of z, right? Because why this is, oh sorry, so you see this is less than I should say this e of z, right? Because z is less than e of z, right? So it's theta times e of z. Okay, so 0 to e z f of z. Okay, and so this is e z, and then this is f of z, right? And I can change 0 to infinity, and this is 1, so it's less than this. Okay, because f is a positive function, so if I only integrate to 0 to theta ez, I can change it will less or equal to 0 to infinity f of z dz. So it's 1, so it's less than this. So this is why we can say the first term is less than theta e of z. Okay, and the second term is theta e of z to infinity z f of z dz. So using the Cauchy-Schwarz. Okay, so the difficult one is that how you need to separate this into two functions. Okay, so the key idea is that I separate into z squared f times f, right? And this is our first function. So basically it's z squared f squared times square f squared dz, and take a total square root. So remember this is this function. So basically you get the f of fg dx less than f squared half integral half g squared half, right? So in this case f is z square f, g is a square f. Okay. So the first one is z square f square and the square f square. So the first thing is the first term is z square f dz square root from theta e of z to infinity, and next one is f dz theta e of z take to infinity. Okay, so the first term will less or equal to expectation value of z squared take a square root because what? So let's recall that e of z squared will be z squared f of z dz from 0 to infinity, right? But in this case, I only integral from theta e of z to infinity, and which this guy is positive. Okay, so I can change it will less or equal to this and then take the square root. And what is this guy? This is the PDF function from theta e of z to infinity, which is exactly z greater than theta of z take a square root. Okay, so combine this guy. This is e of z will less or equal to theta e of z plus e of z squared take a square root times p z greater than theta e of z take a square root. So you combine this and this. Okay, then next is stupid thing. You just shuffle the z to theta e of z take a square root will be this. Remember that the theta is from 0 to 1, right? So this guy will greater or equal to 0. So if you have a greater than b greater or equal to b, then you can square. You can take a square. You can square them, right? So p of z greater than theta e of z will be greater or equal to 1 minus theta squared e of z squared divided by e z squared. Okay, so this is a proof, a detail of these Paley Zygmund inequalities. There's a generalization that I want to talk about. This is called Holder's inequality. So remember that if you don't know about this is Holder's inequality. Okay, so if you don't know about the Holder's inequality, go to my video channel. Go to my channel and type Holder's inequality. I have a detailed proof. So a proof basically is like the generalization of the Cauchy-Schwarz, where if you have two integers p and q, then 1 over p plus 1 over q is 1. Then you will have fg dz integral will less than f to a p dz integral. Take a 1 over p, that part 1 over p, and the integral of fq dz and the 1 over q. Okay, so the stupid idea, right? The key standard, the key step, easy writing as this. The same strategy. So the first thing is will always less than theta e of z, right? And then the second one, you just use the you just write this f as f1 over p times f1 minus 1 over p. And the first term you take the power p, you get z p f dz 1 over p, and you take the q, right? So f to q 1 q divided by dz z 1 over q. So the first term is theta e z. The second and this term will be less than z e to a zp, right? Because this is to a zp, and now you change theta e z to 0. So get this. And the second term by definition is pz greater than theta e of z to 1 over q. Okay, so combine those two, you get ez 1 minus theta less or equal to ez to a p. Pz greater than equal to theta is ez 1 over q. So you just shuffle them and just take what? I think it's take a power q. Then you can prove this. So this is the exactly generalization. If you let p equals to 2, you get back. You get back to your Paley Zygmund inequalities. Okay, basically this is the all the video I want to say. And the next time we will prove this catalysis inequality. Basically, there are many like Chernoff bound. There are many like probability inequalities, and I try to make a series of video and prove all of these things for you guys. Okay, so be sure to subscribe to my channel, and sure, I will see you guys in the next videos.